Hello. Everybody can hear me? Hi. Welcome to Preaching to More Than Just the Choir. Of course, nothing works. Wow. Next slide. There we go. I'm Mr. Glass, Area Silvermans. I'm a developer at Aon Cyber Solutions. They have no idea what I'm talking about here today. They were very kind about sending me here, but none of this represents them. This is all me. I'm involved in all sorts of community things. Many of you know me from there. If not, hi, Mr. Glass. Been a developer for about a decade now. Worked at about 10 organizations because startups are terrible. So if you like talking about that whole scene and the craziness that's involved and why you end up in 10 jobs in 10 years, I can. But the good thing is I've had the opportunity to work in a lot of organizations, and every one of them works differently. Work with a lot of different technologies and wear a lot of hats as you change roles. So I really got a whole breadth of what's going on. Focused mostly on back-end web application development and security. So while I do front-end jobs occasionally, most of what I do is APIs, authentication, things of that nature, as well as cloud engineering and applications like that. I often get suckered into CI/CD ops work. So for those who don't know, CI/CD are continuous integration, continuous delivery. It's a terminology in DevOps for automated processes for building and publishing code. We'll get into that a lot more later. I often get into that for two reasons. First of all, startups are small. You only have a few people on your team. Somebody needs to do work. Being back-end, I tend to be more into the Linuxy server stuff than the front-end developers, so it often falls on me. And the other thing is DevOps. Just the general move in the world to integrating these specialties means that I've had to learn more of it and do more of it. So I often end up being the guy on the dev team who spends a lot of his time doing ops work. And I've always been obsessed with security, going to DEF CON since college, things like that. So I've always ended up being the guy who did the security work at the company. And more recently, I've actually ended up in more of a security resource role sometimes. So I've also done compliance work in small organizations and things like that. That's me. What we're going to talk about today. So this talk comes from a bunch of rants on Twitter. Basically, since I've been in this community for years, I've seen all sorts of people who get angry when a developer won't listen to them. Or why can't the developers just do this right? Or why can't we do this? And half the time, you're totally right. That developer's being annoying. He should be fixing his damn code. But half the time, it's like, you don't understand. There's hours of processes involved. And it takes 2 days to publish something. And there's all sorts of stuff going on. And if you spent time learning how developers work and how you can work with them, you might actually get them to listen to you. So this is what inspired me to make this talk, is just all these rants of people who don't know how developers work, haven't worked with them at all, and don't spend the time learning. And so that's what I'm here to talk about. I'm going to tell you the process we go through for developing a product, the different, I'm going to touch on Agile a little, but not a whole lot, and how you can integrate into Agile, as well as how you can use what we have, the tools that we use for other work for security purposes, and use your leverage as a security person to get security features built in by the dev team. So developers, our focus is shipping features. That's what makes the company money. When you work as a developer, most of us tend to want to go and dig deep into a subject or spend hours figuring out this one little bug, right? But you spend 10 hours fixing a one-line bug that you could have done by duplicating that line of code somewhere else or something. You've just wasted a ton of money and time, right? So we have to balance good with actually getting something out the door. And this is kind of pervasive in what I do now. It's a lot of what Agile is about. And so we have a mentality about pushing code out the door. And so we don't necessarily go through like the process you would do if you were writing code at home. Or like we don't dig in and learn a subject fully. We just can't. Okay, so this is a bit of a rant. If you saw my bio on the website, you might have read that I hate DevOps, DevSecOps. Anybody want to raise their hand and tell me what DevOps is? Okay, that's a different one than I have heard. It's good that you bring up Agile, though, because DevOps reminds me of Agile and that it means something else to everybody. Everybody has, no matter what company you go to, they will do Agile differently than the last one you are at. Agile has a bunch of principles. Most of the places that do it end up sticking to those principles. But DevOps has been a little bit different. DevOps started right when I was getting out of college. And the idea was, hey, you know, the operations team is siloed, the development team is siloed, the security team is siloed, right? Let's go ahead and make these people work together. Let's collaborate. Let's automate and use coders to do some of the ops work. Let's work together and do this right? And originally DevOps had a huge push for automation, both for reacting to high load and for optimization and things like that, and also for automating processes so that they couldn't go wrong. So build processes and things like that are heavily automated now, and that's the DevOps world. That's all from DevOps, and that's great. But what happened was they stopped talking about this very clearly, the businessy people. That was the horrible clip, you know, horrible stock art of business guy. They stopped saying that, and it started being more like this. Oh, hey, all of our developers are responsible for all the security and all the ops work. And I literally have interviewed at companies where like everybody's expected to be responsible for all the ops, everybody's responsible for all the code, everybody's responsible for this. And this sounds great in theory, and I'm not trying to be here and say I have no responsibility when the server goes down. I am also on doing things to fix it, but we don't know ops. Developers don't understand how Linux works, right? My favorite example is, what's an inode? I've heard of it once when a server crashed, and the other developer who had heard of it before fixed it, right? And we don't know how these things work. An ops guy is trained in this stuff, and we have no idea, and there simply is no way we're going to get that knowledge. So when you make DevOps in your organization, like we're going to be DevOps now, you all are in charge of DevOps, they won't know what to do. And it's not like you can send them to a DevOps training camp. They'll learn the automation stuff, but they're still not going to know how Linux works. The only developers I've met who could fix like the Linux server is broken and we need to bring it back alive were ones who are obsessive open source freaks who did that as a hobby. You need a trained ops professional. And the real reason for that is this is your typical learning curve. This is a horrible graph that I just made with like Sharpie. It's untrained worker, right? And then you slowly learn, and maybe it gets harder or easier as you go up, and then you hit a plateau when you're an expert, and you don't learn much after that because you've learned most of it. That's fine. When you're a developer, you're always on this learning curve. Every day is another puzzle I have to solve, usually lots of Googling. And so you end up doing learning, but you have to stop. Again, you have to ship features. So typically I get to about there, which is literally about 2 minutes after I've gotten the level of knowledge where I'm comfortable pushing my code. And that's it. So if I need to figure out this Linux problem, I learn enough to say, hey, I have solved the Linux problem, and I don't learn how the file system works because I don't need to. That's the efficient thing for the business, and that's my job. What we need to do instead is break down walls, work together, you know, have teamwork. We cannot have people who are good at all these specialties at once. It's simply not possible, right? How hard is it to get skilled InfoSec people? Right? You're going to get a skilled InfoSec person who also knows ops and who also knows development. It's not happening. So most of the teams I have worked on that have been good, and what I look for now in a company is these cross-discipline product teams. You have anywhere from 4 to 10 people, and they have everything on the sun. You'll have your developers in the room. You may have your ops people in the room. You may have QA engineers in the room. You have design. You definitely have a project manager. These are everybody involved in the process. And the thing is, especially on the technical side, you want to have everybody's knowledge. So like this is our backend, this is our ops guy. Everybody has a role, but you all share in these responsibilities. Everybody does like 10% ops and 10% this and 10% that. And when they have a problem, you don't do what we call in my company now is throwing the ball over the wall, right? I have this thing, I'm trying to fix it, I need ops help, I cannot figure out this ops problem, I call the ops guy, and we don't just say, here, ops guy, here's a broken server, fix it. No, you sit with the ops guy, you pair up, you figure it out together, and then the next time that server breaks, you both can do it. This is the only way to get them to learn, this is the only way to share real specialty work, and it prevents mistakes because you have the good ops guy paying attention to what they're doing, and this is the best thing, and you end up with people who have some of that skill, but again, will never have that real ops person knowledge. All right, I'm sorry for the long tangent about DevOps, but it kind of is a background for what we're going to go into. But let's talk about now Agile and sprint planning. Sprint planning, backlog grooming, these are parts of Agile. If you want to learn more about Agile, there are entire talks about Agile specifically for the security audience. Circuit Swan did one a couple years ago at BSides, look it up. You can learn all the different parts of the process and the principles and whatever. The problem with Agile is every company does it differently. So my company doesn't have backlog grooming. So as much as in some companies, all this planning I'm going to talk about would happen in backlog grooming, some of it in my company happens in sprint planning, because that's what they do. But you should talk to the project manager and get involved in their Agile process. These planning meetings are all team members who have any stakeholder in the project, right? So QA, the salespeople sometimes will show up, the project managers, the product managers, and the core of Agile is this collaboration between these two teams. Before Agile came about, you had what was called waterfall process. Somebody would sit in the room, decide what the features would be like, write an email, send it to the dev team, and the dev team would stare at the email and go, okay, I'll make a web page that does that. But you run into issues right away, you need to collaborate, you need to talk to them. So Agile is about everybody gets in a room, hour or two a week, sits and talks about what are the features we're building this week, and you go through all the problems. And the developer might go, oh, you know, it's hard for me to build a three-dimensional table like that, but you know, if we get rid of this part of the feature, do you care about that? Okay, it'll take me a 10th the amount of time, right? And that you can only do that if you have this cross meeting, which is why you should get involved in it to ask for the security stuff, right? You're the stakeholder for security now. So get involved, ask to be added to the meeting invite, check the agendas. You do not need to show up every time. You do not need to say anything half the time. So my product manager is in the meeting every week, and I've heard her say 5 words in the past 2 months. But if we have a question, we turn to her. You do not need to go to every meeting, and especially if you start going to these meetings and you start establishing yourself, you can get to the point where they'll come to you with problems. So your goal is to ask for security features in the requirements. So hey, you're making a new login page. Can you make sure the login page is MFA? Can you make sure that the login page actually doesn't let you in if you enter in the wrong password, right? These are requirements. It's very important to get them in early. And you should also raise security concerns. If they're starting a new project that's going to gather a lot of data, you're the person in the room who's responsible for raising your hand and going, hey, maybe we shouldn't gather that data, right? You know, hey, how are we going to secure this data in the cloud? Are you going to encrypt it, right? You need to raise those concerns early. Also want to answer questions. This is my role a lot in the room. There's going to be a new feature. Somebody's asked to make a login page. And they're like, how do you make a secure login page? And then your job is to go and tell them, you know, use this, use that. You help them and establish yourself as this resource they could come to with these questions, because developers are spending all their time trying to learn about the problem so that they can code it. So if you're the resource, they'll come to you and ask you for help rather than Googling it, hopefully. It's important to get your requirements early. I can't stress that enough. Not just because you don't want to be the guy who comes in as we're about to put code out the door and be like, oh, actually, you can't release that. You need to add encryption. Like, that will make you enemies fast. It always happens, and every team, there's always a change in requirements at the last minute. But if every time there's a release, you're coming in at the end and being like that, you're going to make enemies, which is why Agile was invented. It was to prevent this like long process of developers are working on a thing for 3 months, and then somebody goes and sees what they asked for, and it's not what they asked for. So get involved in time, get your requirements in early. It also helps because the team needs to estimate time, and if the requirement is in there, they're not going to put time in for it, right? Often companies will have a QA person whose entire job is going down the list of requirements and making sure they're actually fulfilled. So if you want, during the process of this feature going out the door, somebody sits and goes through and makes sure that security feature is in there, you put it in the requirements. And often they'll actually be added as unit tests, so it's not even a manual person. So every time the code gets tested with the unit test program, it'll run through a test of whatever security feature you want. So you get it in the requirements, and you get all these things that we use for general software development, right? But you can do them for security too, and there's no reason not to, but you have to get them into the requirements. You can also ask for security features, right? MFA is my favorite example of this. MFA is a feature. It is a strong authentication mechanism. Companies sell it. Companies sell it as an add-on that you have to pay more money for. How is this not a feature, right? So go and add it to the feature backlog, and that gives you a different status. This is no longer a bug. This is something we're working on. This is a product we're shipping. Well, but it's not a functional requirement, right? This isn't a requirement. So requirements go on features. Requirements are, when you're making a login page, it has to do this. This is more, we're going to add a new application thing to our application. It's going to do something new. So ask for security features, right? People are, whole sorts of companies are selling encryption and MFA as add-ons to their existing web applications. So, get in this feature to get you a whole new status, and developers, now their job is to work on your feature, and you're not even a bug slowing them down. Buying engineers time to refactor code. So we don't get to decide what we're working on most of the time. And we'll sit there in the meeting and we'll go, man, I really want to fix, the servers. The servers keep breaking on us, but, we have this quarterly project due, and I need to get that out the door. Literally a conversation I had with my boss yesterday, right? So I have to stop working on the servers, and I have to go get the project out the door. If you come into security and you're like, no, this is vital, this needs more time, this needs to get done, you're changing these priorities. And now that quarterly project may get back while I go and fix the security thing. So going in and being like, hey, that thing that's causing you pain points, that piece of code that's causing you issues, that's also causing security issues, right? The authentication keeps breaking. This thing keeps killing servers. This is a problem that keeps hitting us. Go to them and say, hey, this piece of code keeps giving security issues, so maybe go and refactor it. Bolster their arguments for when they want to refactor it, because developers always have a list of things they want to refactor. Similarly, we have a huge list of stuff we want to spend time in terms of infrastructure and tooling. So scripts for automation and deployment, scripts for checking stuff, et cetera. A lot of companies, again, you need to balance developing these intertool tooling with actually getting a product out the door. These are not even part of the product, right? So this isn't even like, oh, I need to fix this bug, or I need to deal with this issue in the product. This is completely, the customers will never see this. All it does is make our jobs more efficient, right? And devs love that because we're lazy. So if our job gets more efficient, it's easier for us. But we aren't given time for that. Log aggregation, automated testing, infrastructure as code. So the idea that you hit a button and it makes your servers for you based on a script, right? Monitoring. All these are tools that developers often are like, yeah, we should really turn that on, but we don't have time. And if you come in as a security person, it's like, we really need monitoring for our security apparatus too. Now you have two people in the room who want this feature, and it gains priority. Leveraging DevOps tools. So most companies, every company I have worked at, and most companies out there, have an automated process for doing their builds and getting code actually up onto wherever it's going, right? This is actually, I mostly work in websites, a lot of terminology I've used in websites, but the same stuff happens with phone apps, the same stuff happens with Windows, with computer applications. Everything these days goes through the CI and CD pipelines. They check out the code, they test it, they build it to see if it builds right. They then go through a functional test, etc. They do all sorts of things. And the thing is, these are all pretty much bash scripting or something similar. You can hit a button to do it. You can trigger on event. So a very common one is, hey, run all these tests every time somebody does a pull request or somebody merges to master, right? Or you can do it on a schedule. I have stuff that runs nightly, right? Or every single time we hit the build button to push code out, just stick this in there, right? And they're all built for alerting as well. So if something goes wrong or you want alerts based on what you're checking, you can get that, right? So it's typical to do unit tests for just general features, code linters to check style and things so that the code stays nice and it's easy to maintain and also make sure it works. Simple check scripts like that, and also build the application, actually run it, of course. But you can add security checks. Writing functional tests, I don't understand why I don't see these more. It takes you about 2 minutes to write a test. There probably is already a test, actually, that goes and logs in as somebody, right? It'll take you 2 minutes to take the code for that test and modify it to put in the wrong password and check that it says password incorrect, right? How many websites, every year or so you hear about a website that just stopped checking passwords and let everybody in. If they added something like this, it won't happen, right? You can test the access controls in the same way. You can test your input validation. I have caught scripts that, like, taking input, had input validation code that was running and always returning true, right? Oh, it's valid. It's just always valid. So I've caught that by having these tests that actually put something bad up and see that it says, no, invalid. So you can write those tests. You can ask them to be written. You can also just run pre-made tools. So literally add in a bash line that runs something that checks all your packages in your package manager. Every package manager has it. There's static vulnerability analysis stuff as well. So again, you run this script and it checks for known things that often go wrong or known problems like SQL injection. Right? It's very easy to look at code and say, hey, this might have SQL injection. So you can run the static analysis and it'll alert you. And you can program it to email you, pop up in Slack. Every day now in my company, I have, we run all of our unit tests, including the security ones, are full functional tests. So it actually goes through a full usage of our application. It checks all the libraries for security vulnerabilities, and I'm looking into different static vulnerability analysis tools, but they're very, they're noisy at first, so I haven't turned any on yet. But every morning at 9 a.m., I get a little alert in Slack whether this all passed or something isn't right? And I've caught, in the past 2 weeks, I've caught 3 vulnerable NVM dependencies because every day I get an alert, whether it is or not. If you want to do more of this, and this is my favorite thing to do right now, there was a huge conference a few days ago called All Day DevOps. It was all online, and all the videos are online now. And they had several talks on just this. They had a DevSecOps track, specifically on security, and they had several talks on just the tools and how to run them. Okay. At a certain point, you're going to need to walk over to the engineering team and be like, hey, you guys have this horrendous bug, right? You don't need to go in and go, hey guys, we noticed that you're not actually checking people's passwords when they log in. Hopefully that goes great. If that team goes, oh my gosh, that's terrible. I mean, if it's not checking passwords, they're probably going to be, oh my gosh, that's terrible. But if you're like, you know, there's this bit of code and you can't actually run this unless you're an admin, but if you do that as an admin, you can then do this thing and that triggers a vulnerability, developers might go, uh-huh, and that's a problem? We have many stakeholders. This goes back to the buying us time argument. So if you come to us with that problem, we might say, listen, I'm not saying it's not a problem, but I have bigger fish to fry, right? I have a long list of features in my backlog. Like, literally, you want this MFA, but there are people waiting a year for multi-tenants, right? Having 2 accounts for the same actual account, right? 2 sign-ins for the same account, multi-tenancy. Engineers, they may not understand the problem when you come to them. You're like, hey, you have this weird problem in the OAuth scheme, and the engineer does not know OAuth. I'm the only engineer I know that actually understands how OAuth works. There are others out there, but I'm the only OAuth guy at every company I've been at, right? So they're going to need to look into it, and they should be willing to learn, and you should be able to tell them, at least get them started, right? So if you come to them and they have no idea about OAuth, recognize that their job is learning every day, right? Patching something is far easier than in theory than in practice. So you go to them and you're like, oh man, can you fix this? And they're like, oh, it's going to take me 2 weeks. You're like, what? It's just going to take 2 days. Why do these developers can't get this fixed out in 24 hours? And it's like, yeah, but you don't know that this framework needs this thing and this. And I've had things that literally should have been 1-line change take 3 weeks. It's just the nature of the beast. And these are all really the things that I hear rants about on Twitter. And like, you need to understand that you're working with people who have jobs that isn't just security. We often don't get the chance to fix. I have been chastised at several companies for working on a fix or dealing with an incident rather than writing code that day. Several times. Didn't stay long. But it has happened because they wanted me to be working on code rather than fixing some security bug that they weren't concerned about. And most important, and I see this a lot, sometimes pen testers walk in like jocks. Like, oh man, your code is terrible, I found this problem. That's how you make enemies. This isn't really a security or developer thing. You know, be nice when you come to somebody and go, hey, your code's broken. You made something bad. Understand that you're walking over to somebody and saying, your work is terrible. And so when you do that, approach it knowing that you're saying that. You have to. Like, you have to go and tell them they did something bad, but approach it that way and know that you're telling somebody something that they're not going to be happy about. That's pretty much it. Establish yourself as a knowledge resource. Try to work your goals into the requirements, into the features. Use your capital buy time for engineers to do what they want. Please, please, please look into these tools if you have them at your company, if you have developers. Please tell them to look into doing it. And be tactful, for God's sakes. Mm-hmm. Right. So that goes to the learning thing, right? If you go to them and you're like, hey, and I looked into it and you need to flip this switch in your library, or you can do this, they'll usually appreciate that. Be careful about talking down to people, right? You don't want to go to a developer and be like, oh, you have a SQL injection. Do you know what a SQL injection is? Every developer has heard of a SQL injection. But they may be like, oh yeah, I've heard of a SQL injection, but how do I prevent that, right? And you need to be prepared to be like, I'll go look into stuff for you, or I'll sit with you and I'll work on it, or here's a jumping off point that I found, this other guy, I don't know about SQL injection, but here's this talk. Be prepared to help them. That's huge, because they don't know security. I've had this thing recently. When I interview people, I ask them 3 basic security questions, and I do web. So I ask them, how do you store a password? How do you prevent against, I ask them what XSS is and what XSRF is. And I have never gotten the correct answer to all 3. Never. Now, these are web developers, right? These are professionals in this field, and they don't know how to store a password, or about half know how to store a password. Almost none can correctly differentiate between XSS and XSRF. Now, it's partly because those are terrible terms, and partly because they don't have to deal with it, because it's all baked into the frameworks now. So usually what happens, do you know what XSRF is now in the cross-site request forgery? I have no idea. It's something with talking between sites. Again, terrible name, cross-site request forgery. Worst name I've ever seen. Some talk about different sites, whatever, and I go, yeah, it's not that. You know that token that's in all your forms automatically for your framework? Like, yeah, that's the CSR token. You're right, yeah, that's prevent this thing. And they've seen it, but they don't know the security portion of it. They don't know why it's there. It's just part of their lives. Any other questions? Alex? Honestly, I really don't think it would be very valuable. I think it's important for developers to be exposed. So I wouldn't send them to training sessions. I'd send them to things like this, right? Give them a day so that they're exposed to it, so they can see the concept, can see how hackers learn. I don't think sitting them in a 5-week course is going to help much. Oh, there definitely is. And I'm not talking about security awareness training. Secure coding practices are interesting, and they're not bad, but they're kind of standard. A lot of the stuff you see in DevOps world, in DevOps now. DevOps has transformed a little bit again, and now it's just modern ops, right? This is what every ops shop does, CI and CD, working together, things like that. And so instead, secure coding practices are part of that, and they're a lot better than they were 20 years ago. So most developers are not terrible about it. And again, you can get most of the secure development practices in a day, right? A 2-hour training course. Just like security awareness, you get to 80% by having that stupid 2-hour thing that we all hate. So I don't think you want to give them like a 5-day intensive course in the middle of nowhere. I don't think there's a huge utility to it. Unless they want to do security, unless they're actually building security features or doing security engineering, or you don't have a security engineer on your team. If you don't have a security engineer on your team, maybe send one guy over to become a security engineer part-time. Can I call and I'll come back to you? Yes? Yeah. So startups in particular, and most companies these days, are obsessed with being flat structures. So, a lot of them they have a manager, but we pretend he's not a manager, right? The main stakeholders in that meeting who actually call the shots will be your product manager. Product manager is in charge of what features are there and what the product is, and the project manager is making sure times are met, things get out the door, etc. So your product manager will know about the thing they're selling. The project manager will know nothing about it, but will know how to get the developers to actually put code out the door. They are the two usually calling the shots. If it's an actual technical question, usually there's some senior technical person, an engineering manager who can call those shots. But usually if it's I want feature A, I want feature B, that's the product manager saying this feature is more important because I manage the product, or the project manager saying you don't have time to spend on that product, that feature, you need to work on this other one. Mm-hmm. Yeah. So I touched on this a little, but I might not have gone into it really. A lot of the cross-functional teams, some of the people will be on multiple teams. My project manager works for 3 teams. If you have QA and design, they're not spending as much time on an individual thing as the developers. So they'll work with several teams. So that's one thing, right? One person can cover multiple teams if the load on them from that team isn't bad, but they can't be in meetings all day, every day to attend these meetings. different companies do different things. The bigger companies have moved toward making secure libraries and other tools like that. So Google, all my Google engineer friends have no idea about security. I say something to them, they're like, oh yeah, what's a password hashing algorithm these days? Because there's a list of algorithms that are approved and they use that, right? If you're encrypting something, you use Google Tink, which is open source, highly recommend it. Encryption library, easy to use. It's made by the security team, the security engineering team, I believe, to be almost idiot-proof. So if you use Google Tink, there aren't all the weird settings that you can get wrong in cryptography. They're not there. They're probably under the hood somewhere. You can probably change it if you want to, but the way you're supposed to use Google Tink, you don't get to change the settings that everybody gets wrong. So they're working on libraries that developers can use without security knowledge. The biggest mistake I see for security is people either not using a framework. So I do web dev, and there are web dev frameworks in every language. People either don't use the framework or don't use the tools of the framework they're in. So your framework will have almost always a form processing library, which will do validation for you. But if you don't use the form processing library to process the form, you don't get the validation. Mm-hmm. Okay. Yeah. Right. Another thing I have done, developers tend to be extremely curious and love learning about this stuff. So if you see an interesting talk that's slightly dev-centric or an interesting article or some vuln, post it in their chat room. Send it to them, right? I've sent the POC or GTFO to numerous developer teams, and they'll go and read it, which gets them in that mindset, right? Gets it in their head. They're thinking about security. It's not going to be anything practical to what they're coding right now, but hey, look at all these weird tricks you can do. Maybe think about what that means for your code. Any other questions? I think we're over time. Thanks. Sorry. Oh, if anybody would like a card, contact me later. Come see me. Yeah. I mean, that's true of libraries and NPM. But that's the known vulnerability analysis, right? So you put that tool in your CI and you just get alerts. There are some companies that have hooked it up and automatically update it, which is a recipe for disaster.
I was paying attention.
Yes.
It was good.
It's fine.
I had to work the whole time.
I figured. This is your presentation remote.